Hello dear friends, welcome to my channel. Today's discussions is residue at infinity. So the residue at infinity is clever device that can sometimes allow us to replace the computation of many residues with computation of a single residue. Suppose that F is an analytic in C except for finite number of C singularities. Okay friends, finite number of singularities. This is my region. This is I called this is C. Okay, and here you can see this region there is a finite number of singularities. Let C be the positively oriented. Okay, this is the positively oriented friends, and contains C be a positively oriented curves, and that is large enough to contain all the singularity. Definition: we define the residue of f at infinity by residue f comma infinity is equal to 1 minus 1 by 2 pi I into fz dz. This is my real line and this is imaginary line. Okay friends, now the definition of residue at infinity assumes all the poles of f are inside C. Therefore the residue theory implies residue f comma infinity equals to minus the sum of the residue of f. And we should first explain the idea here. The interior of a simple closed curve is everything to left as you traverse the curve. The curve C is oriented clockwise, counterclockwise means anti-clockwise, so its interior contains all the pole of f. The residue theorem says the integral over C is determined by the residues of these poles. On the other hand, the interior of the curve C minus C is everything outside of C. There are no poles of F in the region. If we want the residue theorem to hold, which we do, it's that important, then the only option is to have residue at infinity. Define it as we did. So we get the definitions. The residue of infinity assumes all the poles of f are inside C. Therefore, the residue theory means sum of a residue of residue of f equals to residue at infinity. Okay, this is the very important formula. Theorem: if f is analytic in C except for a finite number of singularities, then residue of infinity is equal to minus residue 1 by omega w square f 1 by w, residue at 0. Okay, it is residue at 0. Now we discuss a problem. Let fz equals to 5z minus 2 and z minus 1. Find integral calculus mod of z equals to fz dz. Then solution 1 by w square is equal to f 1 by w equals to 1 by w square 5 by w minus 2 5 minus w into 1 minus w. We easily compute that f comma infinity is equal to minus residue 1 by w square f 1 by w comma 0 equals to minus 5. Since mod of z equals to 2 contains all the singularities of f, we have integrations mod of z equals to 2 fz equals to minus 2 pi I residue f comma infinity. Solutions by Cauchy principle. Fz is equal to 5z minus 2 z into z minus 1. The pole of f are z comma 0 1 and the counter encloses them both. at z equals to 0, gz equals to z fz, a 5z minus 2 divided by z minus 1 is analytic at 0. So the pole is simple residue f comma 0 equals to 2, and z equals to 1, we see the pole is simple residue is equal to 3. So I get fz minus 2 z minus 2 dz equals to 10 pi I. So friends, you see both are equal.